Okay, so to start, vectors, the graphical representation of a vector looks kind of like a ray in geometry, the arrays that you use in geometry, but the main difference is that in geometry, a ray goes forever. Its length, you can't measure the length of a ray because a ray goes forever. But vectors, we use a geometrical representation. The length of the vector actually does mean something. The length of the vector it could represent a force, a velocity, an acceleration, lots of different things. So for example, I could say this is a 20 Newton force pointing in that direction. Okay, so the important thing to understand with vectors is that it's the magnitude, which really means the length, and the direction that matter. The position of a vector doesn't matter. So if I have a 20 Newton force pointing at a direction of, let's say, 30 degrees above the horizon, if I move that to another location, it's still the same vector. Okay? So vectors don't really have a position, they just have a length and a direction. And that's all that's important. Writing vectors in component form, if you think of a vector on a coordinate system, if I had a vector that started at the origin and ended at the point 4, 2, then we would just simply call that vector, if this is vector u, then I could say vector u is the vector in component form 4, 2. So we can write the x component and y component of a vector. Now that doesn't mean that it has to start at the origin. That just means wherever it starts, it's going to go 4 units in the x direction and 2 units in the y direction. So for example, I could start the vector down here at the point 2, negative 3, and vector u goes 4 units in the x direction and 2 units in the y direction. And so there is another copy of vector u. Again, its position doesn't matter. It doesn't have to start at the origin, but when we write the component form 4, 2, that means it starts at, wherever it starts, it's going to move 4 units in the x direction, and it's going to move 2 units in the y direction. Okay, and the advantage of writing vectors in component form, we'll see a little bit later, it's a lot easier to do a lot of the algebra and calculus that we need to do with vectors, for example, adding them, subtracting them. We won't do dot products and cross products in this class, but everything that you do with vectors is a lot easier to do in component form typically. Okay, the magnitude of a vector is just its length. So this vector u that we're looking at, to find out how long that vector is, if we're going 4 units in the x direction and 2 units in the y direction, we've created a right triangle, so we can just use the Pythagorean theorem to find the magnitude. And we use vertical bars that look just like absolute value bars to denote the magnitude of a vector. So the magnitude of u would just be the square root of 4 squared plus 2 squared using the Pythagorean theorem. So that would be the square root of 16 plus 4 square root of 20, or 2 root 5. Okay, so magnitude is a scalar number. It represents the length of the vector, or the magnitude. If this was a force, like I said earlier, if it was a force of in newtons, then this would be 2 root 5 newtons. Okay, so in general, to find the magnitude of a vector u, if we have a vector that in component form is a comma b, then the magnitude of that vector is the square root of a squared plus b squared. Okay, to find the direction angle, that's the angle with respect to the positive x-axis or with respect to the horizon. The direction angle, we can use inverse trig. So for example, looking at this vector that we drew up above, 4 in the x direction, 2 in the y direction, to find theta, I could say theta is equal to inverse tangent of opposite over adjacent. If I work that out on the calculator, inverse tangent of 2 over 4 is 26.565 degrees, or if you had it in radian mode, that is about 0.4636 radians. Okay, in general, the direction angle is inverse tangent of the y value over the x value. So b over a, if we have a vector if u is equal to a comma b again, then its angle is the inverse tangent of b over a. Now that's if the vector's in quadrant 1 or 4. Because remember, the inverse tangent function will only give you answers that are in between negative 90 degrees and positive 90 degrees. So if we know that our vector is pointing into quadrant 2 or 3, what do we do? Does anyone remember? Say it again. Add 180, that's right. And so you need to make a note to yourself to add 100 degrees if u is in quadrant 2 or quadrant 3. Okay, so you have to look at the coordinates of your vectors. If either the x-coordinate or the y-coordinate is negative, then you know you're in quadrant 2 or 3, and you add 180, because the inverse tangent function will only give you answers in quadrants 1 and 4. Add 180 to get into quadrants 2 or 3. Okay, so go ahead and try example 1. Find the magnitude and the direction angle for the vectors 2, 6 and negative 5, 5. Okay, the magnitude of vector 2, 6 is going to be the square root of 4 plus 36, so the square root of 40, or 2 root 10. And the angle is the inverse tangent of 6 over 2. Which is about 1.249 radians, or 71.6 degrees. And then for example B, the magnitude is going to be the square root of 25 plus 25, square root of 50, or 5 root 2. And the angle, when you do inverse tangent of 5 over negative 5, it tells you it's negative 45 degrees. But we know that the vector negative 5, 5, if you plotted the point negative 5, 5, that's in quadrant 2. And so we know an angle of negative 45 degrees doesn't make sense. It's actually, we add 180 to that and get 135 degrees. Any questions? Okay. Vector addition, we can do graphically and algebraically. let's say I have a vector u that goes 2 units in the x direction, 1 unit in the y direction. So that's vector u. And then I have another vector v that goes negative 2 units in the x direction, 3 units in the y direction. I can add those graphically by making a copy of each one and connecting them head to tail. So here's vector u. And then vector v is going to go 2 units to the left. So I start at the end of vector u to start vector v. So I'm going to go 2 units to the left and 3 units up. There's vector v. So see, I connect them head to tail. And then my resultant is the vector that starts at the beginning of u and goes to the end of v. Okay, so that is called the resultant vector. That's what you get when you add two vectors together. And then we can do the same thing algebraically by writing the vectors in component form. If vector u, I'll use the same two vectors that I did graphically. The vector u would be 2, 1. The vector v would be negative 2, 3. When I add those, vector u plus vector v, I just add the x components. So 2, 1 added to negative 2, 3. Add the x components and you get 0. Add the y components and you get 4. So our resultant is the vector 0, 4, which would start at the origin and go up 4 units. So our resultant points straight up and has a length of 4. Okay, notice that that's the same vector that I got when I did them graphically. Scalar multiplication is when we multiply a vector by a scalar constant. So for example, if I had the vector, let's say vector u was negative 1, 7, 5 times vector u just gives us a vector that points in the same exact direction, but is 5 times as long. And in component form, all I have to do is multiply both the x and the y components by 5, so that becomes negative 5, 35. So again, that's a vector that is 5 times longer than the original vector and points in the same direction. Okay? Unless you multiply by a negative vector, like if I multiply by negative 2, then I get a vector that is twice as long and points in the opposite direction. So that would be positive 2, negative 14. So that's a vector that is twice as long and points in the opposite direction of vector u. Sure. Okay, go ahead and try example 2, A, B, and C. Okay, negative 4 times vector u would be negative 4 times the vector 3, 2, and so that is 12, negative 8. U plus v is going to be 1, 1. Add the x's, you get 1. Add the y's, you get 1. And the vector 2, u minus 3v, 2 times negative 3, 2, minus 3 times 4, negative 1. That's going to be negative 6, 4, plus negative 12, 3. So I changed it to vector addition by multiplying by negative 3, and so now it is negative 18, positive 7.
So that's it for today's lesson. Have a great day, everybody.